Good morning, Professor Moussas.
Good morning.
Do you hear me clearly?
Very well, yes.
Great, that's great. Um, I would like to welcome you all in the Bibliotheca Alexandrina. I'm very glad that Professor Moussas is with us today. We have the pleasure of having him with us and that he agreed to participate in the cultural program of the Alexandria Project. So thank you for being with us today, Professor Moussas. Of course, we have achieved this by the great help of my professor, Dr. Magda Nouami, whom I really am deeply thankful for her always and endless support and help. Thank you, Dr. Magda, for all your help and support. Professor Moussas is a professor of physics, director of the Astrophysics Laboratory, and director of the Observatory in University of Athens. He is a co-author of many books, and he has written many articles in journals and during conferences participations. He has also participated in several science activities. Professor Moussas has won several awards, such as Hipparchus Award in 2010. Today, Professor Moussas will explain to us the Antikythera mechanism, which we can call metaphorically the oldest computer. Thank you again.
Good morning. Thank you very much, all of you, Professor Noami, first of all, and naturally your students, and Rania, Sarah, Dina, Randa. Good morning, ladies and gentlemen. I am extremely honored to be with you today for this lecture, in which I hope I will present to you the history of, and prehistory also, of Greek astronomy mainly. And of course, this very old computer that we call the Antikythera mechanism. Although the name of this mechanism, as we will see, originally was tablet. So it is really the oldest tablet that we know. The work I'm presenting here is, of course, the work that I have done with very many people, including scientists, scholars, academics, archaeologists, that we have done at the University of Athens, but also at the National Archaeological Museum in Athens, and other universities like the University of Thessaloniki in Macedonia, Greece, and also the University of Wales at Cardiff of the United Kingdom. And of course, I thank all these people that have contributed to this study, or to the studies that I'm going to present to you. Of course, we are just across the sea, not that far from Alexandria. It's just, even by rowing, a few 2 or 3 days of journey, and people even in antiquity were capable of doing this journey very easily, till very recently. And communication between the two civilizations is continuous. In fact, in ancient Greek books, I have searched, and the term Egypt or Egyptian appears many more times than the term Greek appears in this Greek text. So this really shows the importance of Egyptian civilization and the Egyptians to the Greeks, which continue even more today for very many reasons in present-day world. And Crete is really the entrance to Greece, Europe passed from Crete, according to Greek mythology. And it isn't really a myth, because all the civilization, really as we know it, passed from there as well, from Egypt, of course, first of all. And recently, with two colleagues, Dr. Tsikridis and Mr. Tsikridis, we have discovered something very new, the existence of time models, of calendars in prehistoric Aegean, going probably back to the 4th or even 5th millennium BC, certainly during the 3rd millennium, that's for sure. And of course, this comes from the fact that humans have been observing the time for very, very long. There was a time when there was no TV, I say to the students in the first year. They cannot not really believe it or consider that it's really like this, ladies and gentlemen. And at that time, even today, of course, we have the opportunity to observe the revolution of the sky, to see the stars, how they revolve around the Earth, also the planets, the moon and the sun, and also to count the time it takes for an event to take place, or the moon, for example, or the year, or the periodicity of a planet, of planet Venus, or planet Mars, Jupiter, and all the 5 then known planets to humans that we can see without the aid of modern day techniques like telescopes and space techniques as well. And even eclipses, they count eclipses for very long, and they realize that these phenomena are periodic. They repeat themselves in cycles of time, of course. And this type of events we have discovered in terracotta, in vessels made of clay, like this one we see on the screen, which date from the 5th millennium BC to the 3rd millennium BCE, in fact. And we realize that these patterns that appear time and time on this terracotta represent periods of time. So we have so many days, or so many months, or so many weeks. And if you count the months, the years, or the days, you have periodicities of the planets, and the sun as well, and the moon. And they know quite well the periodicities of all these 5 planets that we see now on the screen, that revolve, of course, around the sun, as we know very well. And they knew already at that time that they reappear in the same place every so many days, or so many months, or so many years. They count all that. And if we have, let's say, the example of Venus, Venus has a very long periodicity around the sun, is a bit less than 600 days, and it has it is divided in several phases, this period of Venus around the sun. And one very important periodicity is the month period that it takes to go from here is the Earth, this is the Sun, this is planet Venus that goes around like this, and from this point to go all around to become invisible behind the Sun, it takes 9 months. And it is for this, I believe, that humans associated women with this planet due to the periodicity of pregnancy. And because it has other very remarkable periodicities, this planet, it is very useful to have it as a mean to measure the time, because Venus goes 5 times around the Sun like this in 8 years. And this is equivalent to 99 months. So it is very easy to have a period of 8 years, which is equal to 5 periods of Venus and 99 periods of the Moon. And all over the world, the Greeks and other civilizations have used this periodicity. This is the so-called Mayan calendar as well, of which you have heard very many things, of course, within the last years. But we have realized that this appears already in the 5th millennium BC in some of these ancient terracotta. Oh, sorry. And we learn from ancient authors, Plato, for example, that the first gods that the Greeks had, called Thei, are the planets. So they were very important for humans, for the Greeks, at least. And they count the time it takes for Venus to go around, and they have this written in this terracotta. Here, for example, we have 8 years, we believe, and 5 periods of Venus. And this appears time and time again. Here again, we have 8 of these spirals, helices in Greek, and helix in Greek has the same root as the sun, and also the same root as the time, the age. And we have 5 periods of Venus. And again here, 8 periods of the sun and 584 days of the period of Venus, as we said before. And this 8 ray star appears in very ancient items like coins, and this is a Macedonian coin, for example, of Antigonus Gontas, in fact. And we again see this period of 8 years, I believe. And again, this is from a Greek island, and time again, we have the same periodicities, several times, and also of other planets, like Mars. All the 5 known planets at that time appear in several of them. And a bit later, around 1500 BC, we have a very special item. In fact, it is a moon. This is a piece of stone. This is 8.5 centimeters in diameter. And it was found in a foundry in a metallurgical workshop where people could create many of these, pouring liquid copper in this mold. And people, Dr. Tsikirtsis and his colleagues, have studied, and they proved that you can use this as a calendar to know when the new moon comes, when you have the new year, the beginning of the year, and also when you have eclipses. Here we have it at a larger image. And this was a portable astronomical device that was, of course, a bit expensive for someone to have a device made of copper, and it seems that there was a market for it. So people around 1500 BCE could use an expensive computer, we could say, or an expensive item, an astronomical instrument, or perhaps even astrological, but mainly to keep a calendar and also possibly to go around the globe, the Mediterranean, and everywhere. And calendars help people to develop better and better astronomy. Because to have an accurate calendar, you can start by observing, of course, the sunrise and sunset during the year. That changes the position of the sunrise and sunset over the year from one month to the other, from day to day even. And you can keep, as it happens in Egypt, in various remarkable buildings like temples. In Greece too we have the same, and this is a place in Knossos, Crete, where you can keep a calendar from the sun, taking into account the sunrise from these doors of the throne room of the king of that time at Knossos, in his palace. And again, a similar one, again from the same place, and many more in fact, all around Greece and all around the world. And we even have observers. There have been many of these small statues, usually found at the top of some mountains that we believe were observatories. Observatories where people like him or her observe the sunrise or sunset. And they know that if the sun rises from the top of that mountain, it is the beginning of the year. And we have these all over Greece, from Macedonia to Crete and all the islands, of course.